Hey everyone, in this tutorial we're going to see how to generate cryptocurrency wallet addresses using the Go programming language. So we're going to see how to generate private keys and public addresses for various cryptocurrency coins such as Bitcoin, Litecoin, or even some of the altcoins. So it doesn't really matter. This tutorial will apply towards a majority of coins that are currently circulating. And again, this is with the Go programming language. This example will make use of several Go libraries from a very popular open source project called BTC Suite. Even though that it says Bitcoin and Go, it does still work with the altcoins as well. I've tested it, it works great. So before we get started, let's go ahead and create a project within our Go path. So I am currently in my Go path. I have a project called Coin Project, and I'm going to create a Go file called main.go, which will have all of our application code. The next step is we need to get those dependencies, so we can say go get github.com/btc suite. We're going to be using btc util, and then we're also going to be using btcd. So these are the two packages that we're going to be using within our project. So I will pause here before we go ahead and open up this project. I do want to talk about something, so that way it's a little more clear as we progress. So if we go to our web browser and when we look at the various cryptocurrency coin projects that we want to use in our generator, we're going to be looking at Bitcoin, Digibyte, and Litecoin. And the reason why I have these Bitcore lib, Litecore lib, and Digibyte lib, so they all make use of this Bitcore lib as the master upstream. But in that information, it has information about the cryptocurrency network. So the network information is very important when it comes to generating wallet addresses for a particular coin. And I'll show you. So if you go to any one of these libraries, you go to lib, and then you go into networks. And it may be a little different for every library that you look at, even those that don't use Bitcore. But generally what you're going to be looking for is network information. It'll be somewhere within the project. And then inside of that project, we're going to scroll down and we're going to look for anything that makes reference to LiveNet. So inside of this LiveNet network information, so this is LiveNet for Bitcoin, we're going to be looking for two different things in particular. We're going to be looking for the public key hash and the private key hash. So what these are byte values that determine what kind of prefix your keys are going to have. So you'll notice that a lot of times Bitcoin keys, they start with the number 1. Or for example, Digibyte, I think starts with the letter D. Or Litecoin, L. These are just prefix values. There's other ways that you can obtain these values. But I found the easiest way is to just look for the JavaScript library, or just one of these existing project libraries. You can even go into the whole blockchain project itself and get this information as well. But you will need these in order to generate accurate keys. So now that we have this squared away, we can actually go into our project. Let's go ahead and go into our terminal. I'm going to open up my project. I'm going to be using Atom. And inside of Atom, I do want to give some words of warning here. I do have a lot of plugins installed for Atom. So a lot of what happens, so for example, when it comes to importing my dependencies, it does it automatically. If you don't have plugins that do this for you, just go ahead and add them on your own. It doesn't actually alter anything in terms of how Go runs. It's just convenient stuff for my editor. So I will type in package.main or package main. And I'll go ahead and create a main function. Before we populate the main function, what we want to do is we want to create a data structure that's going to hold all of our network information. And there's other ways that you can do this. This is just one way that I've found to be very clean for me. So let's go ahead and say type network. That's going to be struct. And inside of that struct, we're going to have a name. So this name represents, is it Bitcoin, Redcoin, Digibyte, so on and so forth. And that's going to be of type string. We're going to have a symbol. So whether it's BTC, LTC, DGB, things like that. So most cryptocurrencies have like a 3 or 4 character symbol. We have the X public key. That's going to be a byte. And then we have the X private key, and that's going to be a byte. And that's actually the prefix information that I showed you just a second ago. So all of this information is going to be stored as a network object at some point. And we're going to actually determine that now before we actually start developing our functions that will generate these addresses. And you'll see where the convenience comes in. At least I found it to be convenient. You may have other or even better ways to do this, but this worked out for me. So I'm going to say var network. This is a global variable to this particular file. This is going to be a map. It's going to be, the key is going to be a string, and then the value is going to be a network. And this is where we're going to define all of our possible networks. And you can have much more than I'm going to add here, or much less. It's up to you. But let's go ahead and say for the first map, so the first key in our map, it's going to be BTC. And for BTC, we're going to give it a name. The name is going to be Bitcoin. The symbol, of course, is going to be BTC. The X public key, let's go ahead and figure that information out. We'll go back to our web browser. We'll go in. So the public key is 00, and then the private key is 80. So public key is 00, and then the X private key is going to be 080. So that's Bitcoin. Let's go ahead and add another one. Let's go ahead. I'll just clone this line. This time around, we're going to add Litecoin. So just minor changes here. This is just to show you how easy it is to generate many different types of coins. So I'll go to my next tab in my browser here. This is for Litecoin. I'll go to lib. I'll find networks. And this is something I don't remember every coin. So the public key is 30, the private key is B0. So let's go ahead and add it. 30 and then B0. We'll start with that for now. I'm missing a comma here. Missing a trailing comma as well. So now let's go ahead and worry about creating some functions. So we're not yet touching the main function yet. We're going to create some functions around actually generating this wallet address information. So the first function, let's go ahead and call this one get network params. And the whole point of this function is we needed to set the parameter information in this network map to the network information that we wish to use when generating our wallet. So this actually matches up with some of the options that we get inside of the libraries that we had downloaded. But you'll see that in just a second. And actually the return is going to be chain config.params. So I'll save it. Chain CF, so it should be a G. You'll notice that my editor automatically added the import for us up top. What we're also going to do here is we're actually going to say, you know what, we want this to be, we want our network to be used in this. So we're going to say network. So let's go ahead and give that a shot. See what we're working with here. So network params, and that's going to equal chain config dot main net params, and we're going to say network params dot public key hash address equals network dot, and we're going to say x pub key. We're going to say network params dot private equals network dot x private key. And then finally, we're going to say return network params. So the network information is going to be whatever we provide when we say something like network dot get network params, and that's going to help us define which wallet we wish to generate. So that's kind of a boilerplate function that we created. What comes next is, well, we probably want to create a private key, provided that one doesn't already exist. So let's go ahead and say function. We're going to use the same network strategy again. We're going to say create, rather than private key, let's say create with. So wallet import format, which is a particular format for a private key. As far as a return, we're going to expect that it returns a Bitcoin util.with, so a wallet import format, or it's going to return an error. So we're going to say secret error equals BTC EC dot new private key, and for the curve value we're going to use a SHA-256 value. So we can actually use a helper function for us, BTC EC dot S256, and that will give us a secret hash. But that's not really something that we can use as far as being in WIF format, so we do have to convert it. We also have to define the network because this is just a generic private key. It doesn't really tie into any kind of particular blockchain network. So what we can say is we can say if error is not equal to nil, then we're going to say return nil because the WIF is non-existent, and we're going to say return that error. Otherwise, it succeeded, and we can say return BTC util dot new WIF. For the private key, we're going to provide that secret that was just generated. For the network, we have to use network dot get network params. Again, this is going to be dependent on whatever network was passed and whether or not we want to compress the WIF key or not. So there's two different types. You can have uncompressed or compressed. Let's go ahead and say that that's true. So that's one function out of the way. And we can actually test that function before we go forward. So let's go ahead and say WIF. Let's say ignore that error. We won't worry about it yet. But we're going to say network. We're going to provide what network we want to use. So let's go ahead and say we want to generate for the Bitcoin network. Remember, this is a map. It's a global public variable here, and BTC is one of our options. We're going to say dot create WIF, and we're going to actually try to print out that WIF value. So we're going to say fmt.print f, and let's go ahead and say %s. And we're going to say WIF.string and save it. So if we go back into our terminal now, let's go ahead and try to run this. We're going to say go run and then just whatever Go file we have. It ran it. Hopefully this, I know that I didn't do a line separator. Hopefully this is a WIF key. So we can actually try doing something else again. Let's go ahead and add a /n there. Let's go ahead and clone these lines. Instead of the colon equals, we're going to say now LTC. So we're going to print out a Bitcoin WIF key and a Litecoin. So let's go ahead and try to run it. So these are two different keys. And then hopefully as we progress, they look more and more like Litecoin or Bitcoin. But if you did try to import this into, say, one of those online readers, it should still work. So let's go ahead and create that next function. This next function might be a get address. So let's go ahead and say function. We're going to provide the network information again. We're going to say get address. And we're going to pass in a WIF, a wallet import format, BTC util.wif. And then the response is going to be BTC util address public key. I think I typed that wrong. Address pub key. Otherwise, it's going to be an error. All right, the first step here is, well, it's going to be one step, and it's just going to be return. So let's return BTC util dot new address pub key, the serialized public key. So we're going to say wallet import format dot private key dot public key, and that's all the information we need. Actually, and serialized compressed. So we're going to compress this key down. We're also going to provide the network information. So whatever was passed, we're going to say get network params, and we can actually save it. So this, depending on what network was provided and what WIF key was provided, we should have a public key at this point, or what we're looking for is a public address. So let's go ahead and try to print it out. So for the first example, let's go ahead and say address. We're going to ignore the error, and we're going to say network BTC dot get address, and we're going to pass in the WIF value that was above, and let's go ahead and print it out in our string. So we're going to say %s again, and we're going to do a comma. We're going to say address dot encode address as a string. We're going to do the same thing for the Litecoin address. Let's go ahead and copy paste here. We're going to remove the colon because it was already initialized. This is going to be LTC. We're going to provide the WIF value. We can actually copy this print line rather than typing it out, paste it in, and let's go ahead and try to run it and see what we get. So this time around, we did get a wallet import format value. We also got a public address value, something that can be distributed to the public so that way people can pay you. The public address for Bitcoin started with a 1, like it should, and the Litecoin address value started with an L, like it should. The last thing that I want to add here, just to kind of finish it off, and we don't necessarily have to test it, but we want a way to be able to import our key value, and not only that, but make sure that it's a appropriate key value. So let's go ahead and add another function. We're going to say function network. We're going to say import WIF. So wallet import file string. So this is going to be a string value. And the response is going to be a BTC util.wif, kind of like what we saw for our create. Otherwise, return an error. And we're going to say WIF error equals BTC util.decode WIF. So this is WIF string. So this will take it and it'll turn it into a WIF. It doesn't necessarily mean that the WIF is the format that you want it to be. All we're doing is really validating that is it a properly formatted WIF, otherwise throw an error. And if there's an error, so if the error is not nil, what we're going to do is we're going to say return nil because the WIF is not good, and also return an error. If that succeeded, the next thing that we really want to do is, well, not only do we want to know if it's a valid wallet import file format, but we want to validate that it's valid towards the particular network that we wish to use. So it wouldn't make a lot of sense to provide a Litecoin private key when we expect a Bitcoin. We want to be able to catch that before it becomes a problem. So what we can do is we can actually say if wif.is for net, and we're going to say network.get network parameters. So if it's not a match, we're going to say return nil. Otherwise, errors.new. So we're going to return a new error, and we can say something like the WIF string is not valid for the, and let's provide the network that it's not valid for. So it's not valid for network.name plus network. So just some kind of useful message. So basically what it's going to say is if we're trying to type Bitcoin and we got a Litecoin address, we're going to say that this particular key is not valid for the Bitcoin network because it'll take the network information from the map that we had created earlier. Otherwise, if all succeeds, we're going to say return wallet import format, and then there was no error for nil. And again, we can kind of validate that. Let's go ahead and say, you know what? We've got a Litecoin address now. Let's go ahead and see if we can do a Bitcoin. So we're going to say, let's go ahead and say WIF1. We'll catch that error, equals BTC, no, it's not BTC, it's network BTC dot get, that's import WIF. The WIF is going to be WIF dot string, because remember we're going to use the wallet import format from the Litecoin that we had created previously. And we're going to say if error not equal to nil, which in this case it should be an error. We're going to say fmt.println, and we're going to say error.error. Let's go ahead and try to run it. It's getting an error already. With1 is declared but never used. You know what? Let's make that blank. So let's go ahead and try to run it. Go run. The with string is not valid for the Bitcoin network, so it's exactly as it should have been. So like I said, let's just recap here because we accomplished quite a bit here. First thing you want to do is you want to determine what networks you want to be able to generate wallets for. I've only provided 2, but like I demonstrated, they're very easy to find. All you need is the public key prefix and the private key prefix. Once you have that information, you can apply it towards the Golang libraries, so you can apply it towards the network parameters, and with those network parameters you can create private keys. You can create public addresses for those private keys. You could import those private keys, and then you could just go ahead and print them out on the screen or do whatever really you want with them. It's very easy. There's not a lot of code behind it, and it's quite convenient. I've used it many times for projects myself.